One of the most practical things that you can use calculus for is to approximate potentially complicated functions with simple functions like polynomials. So here we have the function natural log of x plus square root of x. And for part A, we're going to find the linearization of this function at x equal to 1. So in other words, we're going to try to approximate this function with the line when your x's are close to 1. So to get this formula, we have to have two ingredients, your slope and your tangent line. So we can plug this into the formula. Lx equals f prime of a, x minus a plus f of a. We're going to put the derivative in here, the value of the function there, and create our line. So f of a is our f of 1. What's the value of our function at 1? Natural log of 1 plus the square root of 1. Natural log of 1 is 0 plus 1. That gives you 1. And if you're talking derivatives, f prime of x is 1 over x plus 1 over 2 radical x. And plugging in 1 into these functions, you got 1 over 1, 1. 1 over 2 times radical 1, 1 half, or 3 halves. So the linearization is equal to your derivative, 3 halves, times x minus 1 plus 1. So this function approximates our natural log of x plus radical x when your x's are close to 1. Let's use this to approximate the function at 1.2, at x equal to 1.2. So in other words, you're trying to come up with an approximation for natural log of 1.2 plus the square root of 1.2. And we're going to do this with our linearization. So if we plug in 1.2 into our linearization function, we have 3 halves times x, which is 1.2 minus 1 plus 1. Notice that 3 halves is 1.5, and 1.2 minus 1 is 0.2 plus 1. So you would actually be able to do this without a calculator. And that really is the beauty of things, that you can compute approximations to natural logs and radicals without necessarily using a calculator. So this number is 1.3. If you were to type in natural log of 1.2 plus the square root of 1.2 into your calculator, the calculator will give you approximately 1.2777666672. Are these two numbers close to each other? They sure are. So this number is a pretty good approximation to the value of our function.